Today I would like to talk to you about activity 4.2.2, which is projectile motion. In projectile motion, this is a unit of physics in kinematics, which is how an object moves. Not why an object moves. Why an object moves is with forces and it's called dynamics. But with how an object moves. With kinematics, we're going to look at specifically projectile motion, and we're going to go skydiving today. With skydiving, we're going to look at just falling up, falling down. So we're talking about an up and down motion. Now, before we get to actually skydiving today, we need to talk about some vocabulary, and vocabulary is very important when we talk about kinematics. For instance, speed. Speed is a distance traveled per unit of time. Do not get this mistaken with velocity, because velocity is a vector in which has distance and magnitude. So in other words, velocity is speed plus the direction it's going. Also, acceleration is a change in velocity over a change in time. So, for instance, acceleration, we know acceleration as a gravity, which gravity is a force, but it's also an acceleration. Because of gravity, gravity tends to pull objects toward the earth. And we know gravity as an acceleration at 10 meters per second, or 9.8 meters per second squared, or 32 feet per second squared. What does this mean? Well, if gravity is accelerating an object at 32 feet per second, this simply means that as every second passes, an object speeds up by 32 meters per second. Or, if we're looking at SI units of 9.8 meters per second squared, every second that an object falls, the object speeds up by 9.8 meters per second. I'm going to use this ball as an example. And instead of 9.8, to make the math easier, we're going to use 10. And this is how it works. Notice, I have a ball. If 0 time passes, the ball goes 0 meters per second. But since I dropped this ball from rest, after 1 second, how fast is it going? Well, since acceleration is going to be 10, and the time is 1 second, 10 times 1 is 1 second. So it's sped up by 10 meters per second. We can do this again, dropping the ball. 2 seconds later, how fast is the object going? Well, the acceleration hasn't changed. It's still 10 meters per second squared, except now I'm letting it fall twice as long for 2 seconds. Therefore, 2 times 10 is 20 meters per second. Therefore, as an object falls, we know intuitively, hey, it's going to speed up. Now, let's take our skydiver. Notice that our skydiver here, acceleration is 32 feet per second. So after 0 seconds, notice he's still at the plane, he didn't fall. But let's let him fall for 1 second. 1 second, he speeds up by 32 feet per second. Therefore, his velocity after 1 second is 32 feet per second. Now, we can also talk about 2 seconds. With 2 seconds, he speeds up another 32 feet per second, making his now velocity 64 feet per second. This continues on. 3 seconds, 3 times 32 is 96. 4 seconds, 4 times 32 is 128 feet per second. 5 seconds, 5 times 32 is 160 feet per second. And finally, 6 times 32, which is 192 feet per second. So as an object falls, in the absence of air resistance, it continues to speed up. Now, let's take this single-dimensional problem of skydiving and let's look at it somewhere differently, in which we're going to dare to do something slightly different than skydiving. We're going to become a human cannonball now. Now, with the human cannonball, what are some things that happen with a cannonball? Well, with our human cannon, we can launch it at different angles. Therefore, we need some more vocabulary. Let's talk about a projectile. A projectile is a moving object in which the only force acting on it is gravity. For instance, we know this in a lot of sports with a ball, throwing a baseball, tennis, throwing a football, golf. A lot of your sports in which a ball is flying through the air is projectile motion. Notice that gravity is always pulling on the ball, and that's the only force that's pulling on the ball. Next, we're going to have a symbol. This symbol is theta. This is just simply an angle between what's called the horizontal and our shooting angle. Now, with this cannonball, the ball is going to come out with a certain initial velocity. We denote this initial velocity V naught or V sub I standing for initial. Now, this initial just simply means at the start of its path. So we're going to look at the start and the end. Now, let's look at a simple case in which we fire a ball straight up in the air. When we fire a ball straight up in the air, where is it going to land? It's going to land straight down where it began at. Notice that this gravity that we found, whenever we said velocity is equal to acceleration times time, this gravity is going to slow it down until the ball reaches a high point, and then it's going to speed it back up at the exact same rate. Therefore, if our human cannonball is fired at 128 feet per second, after 1 second, it's going to slow down by 32 feet per second to become 96 feet per second. Another second passes, it slows down another 32 feet per second. They're at 64 feet per second. Another second, so 3 seconds has passed. It's now at 32 feet per second. Next, 4 seconds pass, and the object comes to a rest. We also know that, hey, what goes up must come back down. So it took 4 seconds for a human cannonball to reach its initial position straight up to the top. Now, let's look at it on its way back down. On its way back down, we're looking at the same parachute. It's going to take another 1, 2, 3, 4 seconds to speed it back up to get to its same spot. This is with a 90-degree angle. Now, we've talked about the up and down. Let's talk about the left and right. Notice after 0, 1, 2, 3, 4 seconds, if I shoot a cannonball straight horizontally without gravity simply means we turn gravity off, the object's not going to fall. It's going to continue in a straight line path. In other words, we can say velocity times time is our distance, and with the constant, with our constant velocity, it's going to go the same distance each and every second until hitting our bullseye. But we know this does not always happen that way, because when we turn on gravity, every second the object falls. There's an acceleration. The acceleration is gravity. That's the only force acting on it is gravity, which causes it to go down. Therefore, instead of this object hitting our bullseye, we are going to miss the bullseye, because we do have a gravitational acceleration. Now, we can do experiments, and and people have done experiments, and we have found out that we have something called a range equation. With the range equation, if we can find the initial velocity of any object shot as a projectile by taking gravity multiplied by the range, in which how far from where it started to where it landed, just a horizontal distance, that's a range, x, and divide it by the sine of 2 theta. In other words, we said theta in definition was our angle, our shot angle. Therefore, twice the angle, take the sine of it, a trig function sine, take the square root of all this, and we have our initial velocity of what we shoot out of a cannon. So, imagine I set an angle at 30 degrees and I fire a marble. Just because I fire this marble and I know how far it went, I can plug into this equation to tell you what my initial velocity was. Now, why is that important? Now, because of that's the reason that's important, I can rearrange the equation, and by rearranging the equation, I have now, because I know the initial velocity, I know gravity, I can change the angle and tell you how far it's going to go. So instead of now a 30-degree angle, I can change it to a 50-degree angle, and I can test this out with the marble and tell you how far the marble is going to go, the range of this marble. Or I can also, if I have the initial velocity, I have gravity, and I know the distance, you say, hey, the initial velocity coming out of your marble shooter is 20 feet per second. I want you to fire this marble so that it lands 10 feet away. We can find the angle in which you need to fire this at. Now, with the angle that you fire it at, notice that we have 2 theta. What does this mean? Well, this means that we actually have 2 angles that are correct. Now, because of it, 0 and 90 degrees, if I fire on the ground, which is 0 degrees, or if I fire straight up, notice it'll land in the same spot, right where you began. Or, if I fire at 10 degrees, which is a low elevation, notice gravity is going to pull it down a lot faster, in which it's not going to go that far. Or if I shoot at 80 degrees, which is a high arc, most of the velocity is going to cause it to go up, and it's going to fall in the same spot as 10 degrees. So it's likewise 20 and 70 degrees, 30 and 60, and 40 and 50. This tells you that the maximum range that I can shoot without air resistance is 45 degrees. And this is projectile motion.